I'm going to briefly demonstrate how to use an interactive simulation that models a Langmuir-Hinshelwood reaction in an isothermal plug flow reactor. So the reaction of carbon monoxide and oxygen reacting forms CO2 over a catalyst. And what we're going to look at in the simulation is how the partial pressures change as a distance down the reactor. So let's look at a snapshot of this. So we'll look at surface coverages because it turns out carbon monoxide absorbs more strongly than oxygen, so it actually inhibits the reaction. And as we react away carbon monoxide and get more oxygen coverage, the rate of reaction increases even though the partial pressures are decreasing. And so we'll look at these surface coverages with this simulation and also the reaction rate. Well, we can change the temperature, which changes the rate constant, which makes the reaction occur faster, so we get reaction sooner. We use up the reactant sooner in the reactor. We also can look at reaction rate and see how it increases as we move down the reactor and then decreases, depending on what the relative coverages of carbon monoxide and oxygen are. And so one slider allows us to change this ratio, partial pressure CO to oxygen. So here ratio is 1. In stoichiometry, ratio would be 2 CO to oxygen. And here we're going to look at a ratio that's lower than that because remember, CO absorbs very strongly. So let's look at this simulation. So if I pick a ratio of 1, then I'm going to use up all of the carbon monoxide while I still have oxygen left since of the stoichiometry ratio. And you see, of course, we're forming CO. So partial pressure CO, in this case, we go to complete reaction, drops to 0, and we still have half of the oxygen left. If we look at the surface coverages, we can see that mostly CO is on the surface. Oxygen coverage is much lower. There are no vacant sites until we've reacted essentially all of the CO. Now we have some sites not occupied and the rest occupied by oxygen. So as the CO coverage decreases and the oxygen coverage increases, since in Langmuir-Hinshelwood mechanism, the rate of reaction is going to be proportional, in this case, to the product of the two surface coverages. We expect the rate maximum to be somewhere around here when they have similar coverages. That's what we see. So notice as we move down the reactor, even though the partial pressures are decreasing, the rate of reaction is increasing. And this is because the carbon monoxide is inhibiting oxygen absorption. And then the rate drops off pretty quickly as we use up all of the carbon monoxide. Now, in this interactive simulation, we have some brief directions that says some of the same things I just explained. And we have details that show the equations used to generate the curves. So many catalytic reactions can behave similar to the Langmuir-Hinshelwood mechanism, and therefore behavior that we might not expect for just gas phase reactions, that reaction rates can increase even as the partial pressures of reactants decrease.